Here, we are looking at solving initial value problems. Okay, these are the case where some certain conditions were given and probably some certain variables were assigned some values. Okay, so how do we solve that? So let's look at those steps for that. How do we solve initial value problem using Laplace transform? Initial value problems are just some certain variables, okay, assigned values, okay. So that's just like that. So how do we solve this initial value problem on the Laplace transform? Step one, take what? Take Laplace of both sides of the equation. Take Laplace of both sides of the equation. Okay, two. Then get the Laplace transform, okay, of the equation. Okay, then what? Um, write what? Write the Laplace transform. Write the Laplace transform for the solution or for the equation. Write the Laplace transform for the uh, for the solution or for the equation. Okay, for the solution or for the equation. And then the last one is to take the inverse. Take uh, uh, inverse Laplace. Take inverse Laplace transform to get to get the to get the solution to get the solution. So these are the three basic methods to solve initial value problem. And we're going to look at questions straight away. The first step, take Laplace of the differential equation. Okay, then after that, get the Laplace transform for that equation. And finally, after you have done that, you have done little algebra, then take the inverse, okay, Laplace, okay, to get the solution. So let's look at the question. Yeah, so this is the question we have. We're told to use a Laplace transform to solve this. Okay, I didn't they didn't mention Laplace. We can use another method to solve it, but we are being compelled to use Laplace transform. So step one, this is the differential equation. This is the differential equation, and it's first order differential equation. Okay, so what we do here is step one. Take what? Take Laplace of the what? Of the differential equation. Take Laplace of the differential equation. Take Laplace of the differential equation. Okay, and this is a condition we are given. This certain boundary condition you are given that when x is 0, y is 1. Okay, so so this is what we have now. Then we're taking step one. Step two now. Let's get, if you open this bracket, then you have Laplace of this. Okay, then Laplace of 3y, and then Laplace of e3t. Okay, then let's get the Laplace transform. At least Laplace of first differential. That's an expression. Let's get that the transformation for that. So this one will give us x Laplace of y, y, probably y of t, if you want to, and minus y of 0. That's for this first one. That one is done. Then minus Laplace of 3, Laplace of 3y. The 3 will go outside. Then we have 3 Laplace of y. Okay. Then this one, Laplace of this, give us one exponential. That's 1 over x minus 3. Okay. So, and then for the initial value problem, this one is equal to what? This one is equal to 1. So we can combine this one and this one together, and that will be what? That will be x minus 3 Laplace of y of t equal to what? 1 over x minus 3. Okay. Then we can move this 1 here, this minus 1 here to other side. That's plus 1. We can do that. Do that. So with what we've gotten now, we now have now, we can make um, the Laplace the subject. Make Laplace the subject, and that will be equal to 1 over x minus 3. I'm dividing now by x minus 3. So this will be squared, and then plus 1 over what? X minus 3. So this is what we have, okay? Then the last thing is to uh, get the inverse, so I can get y of t. Take the inverse Laplace of the equation, and that will be equal to what? If you take the inverse of Laplace of a function, that will give you the Laplace of that function, and that will be equal to what? Inverse of what? Inverse of 1 over x minus 3 or squared plus 1 over x minus 3. Okay, and that will be equal to inverse of this, then minus plus inverse of. So, and this one will give us, inverse of this will give us, that's 1 here. So, don't forget that. Okay, so this will be equal to E3t, and then that will be t. That will be t. I will explain that. That will be t. Okay, then plus E3t. So that's the answer for that. That's the solution. That's the solution. That's the solution. Okay, let me just recap. Let me just take us memory lane. The inverse of n factorial, okay, over x minus a, okay, x minus a to power n plus 1. If you remember one of the properties, so this will give us what? This will give us Tn. This will give us Tn, and then EAT. Okay, EAT. So that's that. So the inverse of this one will give you this. It's just a table. It's just a normal standard table. Okay. So, and if you take the plus of this also, you get this one back also. Okay. So that's just that. That's just that. That's just that. And that's just that. That's just that on that question.